Hello everyone, welcome to this segment where we're going to understand what is merge sort. So merge sort is an sorting algorithm which uses divide and conquer approach. So what is divide and conquer approach? It is basically we are dividing the bigger problem into smaller sub problems and solving that sub problem itself solves the bigger problem. So this is what like we are dividing the bigger problem which we have initially assigned to individual small problems and finally trying to solve that small problem, and that will ultimately help us to solve the bigger problem. So that is the basically approach we are going to use in merge sort. Now in merge sort we are basically dividing the currently unsorted list to two equal halves, and until we are remained with individual elements, and finally once we are done with the division part, then we try to compare the elements, and based upon that we create a merge lists, and finally we merge the subset of this particular list, and finally we create the merged entire list at the end of this particular iterations. So we are executing the division, then finally we are merging the value. So accordingly we are finally getting the desired output as sorted output. So let's understand the merge sort algorithm by using this particular example. So here we have taken an unsorted list containing 6 elements. In merge sort, we are dividing the elements in two equal halves initially. So here we have, as this is the middle of this particular list, as it is 6 elements list. So we have taken 6, 5, 1, 2 as in one part and 10, 9, 1 as in other part. Now we are keep on dividing it until we are getting one level. Here is the level in which we are getting all elements in an individual data, means individual segment. It's not in any combined state. Now all are in individual level, so it is all are in figuring out. So this is the point until we need to divide our particular list, and keeps on dividing until we are getting until this level. So this is the division basically. Now this is the part where actually we start our merge part. So in this merge part, what we'll do, we compare the finally individual level data and finally combine into a single list. So this 5 and 2 is compared, and accordingly we see that 5 is the smaller, that is come first, 12 is the highest, so we have taken 12 here and finally created a merge small list or the sub list we can say. Similarly we create a 9 and 1 as consideration, and accordingly we have combined them because one is smaller, so we compared both of them and finally created a merge list. And finally we now have in this level we have 6 and this list. We compare these two lists and finally create a small list here. So as it is a 5 is a smaller value, it will come first, followed by 6, then 12. So this is the merge list, which is not the final solution but the intermediate solution of this particular two list we have above. Now similarly in 10 and 1 and 9, so similarly here they are one list and this is one list. When you're comparing these elements, you finally see that 1 is coming first because 1 is the smaller, followed by 9 and then 10. So finally we are checking this one and this one, and once we are comparing this one elements, we figure out that 1 is coming first, then followed by 6, then 9, 10, 12. So as you can see, we have individual level, we have divided the particular elements, and once we done the division part, we are comparing the elements and finding the merging part. So individual level, we just whenever we start merging, all lists or the smaller list are sorted itself. This is sorted, this is sorted, this is sorted, this is sorted. Similarly this one is also sorted, this one is sorted, and finally the ultimate sorted goal. So by this approach we are basically trying to use the divide and conquer approach, that is the ultimate goal. So this is how merge sort actually works. Now let's understand the implementation using Python code. So let's understand the implementation of merge sort algorithm using Python. So in this particular example, we have taken an unsorted list and we're passing the reference of that list to this function, which is currently not defined. We will define the function now, which will be running the merge sort algorithm on this list, and finally we get the sorted output. So let's begin. So first check we are going to do is that if length of the list is greater than 1 or not, because if suppose the length of the list is equals to 1 or less than 1, so there is no meaning of doing the sorting, because a single element itself a sorted item. So this means we always going to check that whether the list is containing the values greater than 1 or not. The second thing we need to is determine the mid index value. How can we find the mid index value? So simply we will do len of the list divided by 2. Now we figured out the mid of the particular uh, list. Now as we figured out the list mid value, now we need to segregate into two halves, the left part and the right part, because as we know in merge sort we are separating the particular list into two equal halves until we are remain with single individual. So we are first of all dividing it. So to approach the dividing part, we have to first of all create the similar type of left half and the right half. So we write the same thing. We write first left and list of starting from 0 to the mid value. And also the right part we can implement as n list to the last elements. So this is the right half and this is the left half we have now. So once we have defined the segregation of two separate lists, which is the sub list, or we can say the smaller parts of the entire list. Now we need to call the merge sort again recursively on this particular small lists. So we have to write merge sort, and here we'll pass left and here we pass right. So this part will entirely take care of the division of our entire list to single individual elements. Now here we are done with our division part. Now we'll start our implementation of the merging part. So we'll take three variables: I equals to 0, k equals to 0, and j equals to 0. What is the purpose of ijk is that I will track the index value of the left hand side, j will track the index value of right hand side, and k is the index value of the merged list. So what I mean is by we can take simply understand with an example. So we have a particular list. Suppose we have a condition like this, in which we are containing some three datas: 2, 4, 9, 1, 7, 23. So this is the left hand side, this is the right hand side, and we are merging this list to this final merged list. In this scenario, track the index value of the left hand side, I have taken variable I. To track the index value of right hand side, I have taken j. And to track the value or to add the value this particular merged list, the final list, is going to be k. So this accordingly I have mentioned as an initialization. So now let's begin the traversing now. So we'll write while. Now here we'll first check whether I is smaller than length of the left and j is smaller than the length of. Why we are checking this condition? Because we are now in the merge list, we are taking decision basically. How we are taking decision? We are comparing the first element with the right hand side first element. We compare that and figure out that okay, right hand side first element is smaller. So we'll put 1 here. We'll just make it gray it out, and we will increment the value of 0 to 1. And now j value is 1, and it is pointing to this location, not this location now. So in the next comparison, I will compare 2 with 7. And again, I saw that 2 is smaller. So 2 will be come here. And after that, we will just gray it out. And after this, 0 will be cancelled out to increment to 1. Similarly, we will follow the same fashion for all the things until we are done with the merge list. The same thing we are checking for the conditional checks. It is basically checking whether all the particular elements are perfectly in place or not. Now, in this first segment, we will check if ARR, or the left side which we have here, that is called the left hand side value of I, is smaller than or equals to the value of right hand side j, then we are finally going to append that value to our main list. So n list is our main list. So we are going to append that value there, and here we are going to append that value as left of I, and we increment I to I plus 1. Else we are going to do the opposite, which is we will append it with the right value, here. Now once we did with these changes, we are here mostly checking that what is the current value which should be inserted first by comparing the left and the right hand side. Now we will increment the k value, because once the data has been inserted, we need to increment the k value so that the main list also get incremented here, because we started with k0. Once k0 is filled, we need to proceed further to k1, to k2, k3, like this. So similarly, we have to proceed further. For that, we have written k plus 1 here. Now this is the most part which you have to understand on whenever we have left hand and right hand side, how we are pick out the elements to finally put it into the final merge list. Now going to the next implementation here, while I smaller than len of left. No, why we have written this particular line is because suppose we got a situation in which we are in this particular right hand side, uh, and the left hand side whatever we have the data in the merge list, the entire left hand side data has came already. From the right hand side some one data came, and from the entire left hand side all the data came here, and the right hand side data also came here. Remaining two are there with me. Now in this situation, we don't have to do any comparison now. Why? Because we already know that left hand side whole data is come already, this list is sorted. We directly just copy this to directly the other places rather than any comparison. So in this part we just have to copy the data from here to here. So we can apply the same functionality using this while loop. For the left hand side, if suppose left hand side is remaining with some elements and right hand side is already done with all the elements, in that fashion we can copy the data from here to this particular location. So this applies for either for this part, the case one will be in the right hand side maybe, or in the left hand side. So we will put a while loop accordingly. So in this section we have put it for the left hand side, but now we'll put for the right hand side as well, similar to the left hand side. So mostly we are done with our implementation here. Initially we have started our implementation using first of all separating or dividing the entire list into two parts, then finally dividing into the individual elements. Now we started our merging part. In merging part, we're taking the left hand side and right hand side, comparing the elements inside it. As it is initially in individual status, it is sorted. So we keep on checking that which is the element which is going to be come in a merge list. And finally, we start merging the data by keeping a track of the index value in K. And finally, when we are done with this part, so once one of the whole entire list is done and remaining elements which we have, we can directly copy paste by either of these particular segments while loops we have. So this is how we can implement a merge sort algorithm using the Python code. Now let's execute and see the result as well. So as you can see here, we are getting the output as expected. So it is entire list is now sorted and all the datas are currently coming after this algorithm has run its job. So this is how we can implement using Python. Thank you.